Alright, so when we complete the square with quadratics like this, you know the drill, right? We wipe out the constant that we already have, add in b over 2 squared. So today, like 50 videos ago, I think I promised I'd explain why we do b over 2 squared and not 2b over 17 to the 12th. But yeah, I'm gonna explain why we do b over 2 squared, not anything else. So basically, let's say we have a quadratic like this, right? The quadratic we normally deal with when completing the square, a times 1, right? Let's say, right, that this is a perfect square. So this is a perfect square. We can write it like this. Some x plus alpha, well, alpha is some number, squared. Right? Perfect square. Something squared. Alright. Now, I think what I'm going to do, I'm going to copy left hand side, right? X squared plus bx plus c. And then I'm going to expand out this side real quick. Alright? So I get x squared plus 2 alpha x plus alpha squared. Right? Simple expansion. Now let's see here. Since these two are equal, I think what we can do, I think we can compare coefficients, right? X squared, they have the same coefficient. Alright, that's boring. Middle term, alright. Compare coefficients. I think we can say that b is equal to 2 alpha. Alright, that's something we can say. B is equal to 2 alpha, right? Let's see, look at constant terms. C alpha squared. I think we can also say that C is equal to alpha squared. Alright, so this is true, means these two equations have to be true. Okay, let's see here. I think I want to do something interesting. Okay, so I'm gonna solve for alpha in this equation and plug it in place of alpha right here. Right, see what happens. So from this equation we'll get alpha is just equal to b over 2, right? Easy algebra. Plug b over 2 right here, and I think you can see where this is going. We'll get that c is equal to b over 2 squared. Alright, so this is big, right? So since this is true, these two equations are true, which means that if x squared plus bx plus c is a perfect square, then c has to be equal to b over 2 squared, right? This is no other way. So this is why we added b over 2 squared, not 2b over 17 to the 15th power. So yeah, really nice simple proof. We got the expected result. Follow for more things like this.